Namaste children, how are you all? I hope you are fine. And in the last class we discussed about the number of tangents that can be drawn from a point to a circle at different places, that is inside the circle, outside the circle and a point on the circle we discussed, and one theorem we discussed, that is a 10.2 theorem related to the lengths of tangents drawn from an external point. That is, the lengths of the two tangents drawn from an external point to a circle are equal. Now, using that theorem 10.1 and 10.2 and some other like Pythagoras theorem, we are going to discuss exercise number 12.2 problems. So, in the last class we discussed the first three bits. Now, the fourth bit from exercise number 10.2. Prove that the tangents drawn at the end points of a diameter of a circle are equal. Prove that the tangents drawn at the end points of a diameter. What is diameter? The longest chord or the chord which passes through the center of the circle is known as diameter. Now here in the figure, AB is the diameter and OA is the center of the circle. Here the end points of the diameter are A and B. Point A and point B. Through point A, PQ is one tangent and through point B, RS is the tangent. So what we need to prove? The tangents drawn at the end points of the two end points of the diameter are parallel to each other. That is, PQ is parallel to RS. How do we prove it? So what are parallel lines? The lines which do not intersect each other are known as parallel lines. So we discussed in class 7 parallel lines and a transversal. A transversal is a line which touches or which intersects the two or more than two lines, and we studied the properties if a transversal intersects a pair of parallel lines, that is, one, the corresponding angles are equal, alternate interior angles are equal, and the interior angles on the same side of the transversal are supplementary. We studied in class 7. Now using those properties we are going to prove this question, that is, the tangents drawn at the end points of the diameter of a circle are parallel to each other. So what is given here? It is in this question, the given statement, it is given here, it is PQ and RS are two tangents. RS are two tangents and AB is the diameter of the circle, with center O, with center O. Now what we have to prove? To prove that, we need to prove what we have to prove here. PQ is parallel to RS. PQ is parallel to RS. This we need to prove. How do we prove? Here it is proof. We studied in class. That is theorem 10.1. What it is? The tangent at the point of contact is perpendicular to the radius. If you observe here, the diameter AB is the combination of radius OA and radius OB. So here OB is perpendicular to RS at point B. Therefore, angle OBS is 90 degrees. Similarly, OA is perpendicular to PQ. Therefore, OAP or PAO is 90 degrees. Here, these two are alternate interior angles. Therefore, PQ is parallel to RS. So, proof. How do we prove this? This theorem or this question it is. So, here OB is perpendicular to RS and it is OA is perpendicular to PQ. It is perpendicular to PQ. So why it is? By using theorem 10.1. Theorem 10.1. These two are perpendicular. Therefore, angle OAP is equals to angle OBR. That is equals to 90 degrees. That is equals to 90 degrees. Both are equal. Now here PQ and RS are two lines are two lines, and AB is the transversal. AB is the transversal angle OAP is equals to angle OBR. Alternate interior angles are equal. Therefore, what we can say? Therefore, PQ is parallel to RS, and hence it is proved. So like this we can prove this. Hence it is proved. So how we have proved this? It is the two tangents drawn at the end points of the diameter are parallel to each other. As we know, these are the two tangents, and point A, point B are two point of contacts of the respective. It is the tangents to the circle at point A and point B. And we know theorem 10 points says that the radius is perpendicular to the point of contact to the tangent. Hence OB is perpendicular to RS and OA is perpendicular to PQ. Therefore, angle OAP or PAO is equals to angle RBO. Both are equal to 90 degrees, and these two are alternate interior angles. Here AB is the transversal, PQ and RS are both are two lines. One pair of alternate interior angles are equal. Therefore, the two lines are parallel to each other. Is it clear, children? Next, 7th question. Two concentric circles. What are concentric circles? Concentric. Centric means center. Con means it is same. Circles having same center are known as concentric circles. Circles having same center are known as concentric circles. Of radii means it is the plural form of radius, 5 centimeters and 3 centimeters. That is, 5 centimeters is the radius of the larger circle and 3 centimeters is the radius of the smaller circle. Find the length of the chord of the larger circle which touches the smaller circle. The chord of the larger circle, it is touching the smaller circle at a point. Therefore, that chord is a tangent to the smaller circle. So what we have to find? Find the length of that chord. See the figure. Here two circles are given, C1 and C2. Two circles, C1 and C2 with center O are given. AB is the chord of the circle C2, that is a larger circle, which touches the smaller circle at point P, and it is the tangent to the smaller circle. And it is given radius of the larger circle, that is OA is 5 centimeters and OP is the radius of the smaller circle, and that is given 3 centimeters. Now what we have to find? Find the length of AB. AB is equals to AP plus PB. AP plus PB. Now we have to find AB means find AP, then find PB. Before that, establish a relationship between AP and PB. We studied already here in the first theorem, that is the radius of a circle is perpendicular to the tangent at point of contact. Or we studied the perpendicular will divide the chord of a circle into two equal parts. We studied in class 9th, the circles chapter. Use that concept, or you use the congruency of triangles. So first you prove these two triangles. Which two triangles? Triangle OPA and triangle OPB are congruent triangles. Then we can say AP is equals to PB by CP/CT. Then apply, these two are right angle triangles, apply Pythagoras theorem and find AP. Double that, we will get AB. Is it clear? Right. Now what it is given? What is given here? Two circles with the center. Two circles C1 and C2. C1 and C2 with center O. With center O. With center O, and C2 is the larger circle. C2 is the larger circle, or two circles with center O, same center is there. Therefore, those two circles are known as what? The concentric circles. Concentric circles. Now here, the two circles C1 and C2 with the center O, and C2 is the larger circle and C1 will be the, what it is, automatically it will be the smaller circle. And it is also given OA is equals to 5 centimeters and OP is equals to 3 centimeters. OP is equals to 3 centimeters. Now, OP is perpendicular to AB. Why it is? Because of theorem 10.1. What theorem 10.1? It says that the tangent at point of contact is perpendicular to the radius. Therefore, angle APO is equals to angle BPO, that is equals to 90 degrees. Now, consider the two triangles. In triangle APO and triangle BPO, angle APO is equals to angle BPO, that is right angle arc, 90 degrees, right angle, and here it is OA is equals to OB, that is hypotenuse, and why they are equal? Because of radii of larger circle, radii of larger circle. So we know the radius is the singular form and radii is the plural form. OA is equals to OB, and the other one it is OP is equals to OP, that is side, common side. Here it is common side. Now by RHS, that is right angle, hypotenuse and side, both the triangles are congruent triangles. Therefore, triangle APO is congruent to triangle BPO by RHS congruency. RHS congruency. These two triangles are congruent triangles. By CPCT, AP is equals to BP by CPCT. By CPCT, these two, that is AP is equals to BP, we have proved. Now you consider any one of the triangle, both are right angle triangles, and apply the Pythagoras theorem. Thereby we can find the AB. AP we can find, multiply that with 2, will get AB. Is it clear, children? Now in triangle APO, angle APO is equals to 90 degrees. Therefore, by Pythagoras theorem, square of the hypotenuse, that is OA square, is equals to OP square plus AP square, that is by Pythagoras theorem. Now OA is equal to how much it is? 5 centimeters. Therefore it is 5 square. OP is 3, that is 3 square plus AP square. 5 square is 25, that is equals to 3 square, it is 9 plus AP square. So 25 minus 9 is equals to AP square, that is 16 is equals to AP square. Transpose square to the other side, will get square root. AP is equal to square root of 16, that is AP is equals to plus or minus 4 will get, but we will consider AP is equals to 4. Why we will consider only 4 centimeters? AB plus 4 will consider, because it is the distance or the length. Length never be negative. Therefore, we will consider AB is equals to 4 centimeters. Finally, what we have to find? AB we have to find. AB is equals to 2 times of AP. Why it is 2 times of AP? Because AP is equals to BB. BP we proved here. Now AB is equals to 2AP, that is 2 into 4 centimeters, which is equals to 8 centimeters. Therefore AB is equals to how much it is? 8 centimeters. What is AB? It is the chord of the larger circle. So AB is equals to 8 centimeters. What is AB? AB is the chord of the larger circle and it is the tangent to the smaller circle. This is one way of doing this sum. By using the 9th class also we can do the same sum. Here the radius OP will divide the chord of a circle. So it is OP is the radius for the smaller circle and it is perpendicular to the called AB. Therefore, AB will divides OP will divides AB. Therefore, P will be the midpoint. Definitely, AB will be twice, 2 times of AB. So, instead of proving that two are congruent triangles, using the 9th class concept also, we can find AP is equals to PB. Then we can find AB is equals to 8 centimeters. Is it clear? Question number 8. A quadrilateral ABCD is drawn to circumscribe a circle. See figure. Prove that AB plus CD, that is sum of the opposite sides, one pair of opposite sides, is equals to AD plus BC, that is sum of other pair of opposite sides. How to prove this? So what is here? It is given in this question. It is ABCD is a quadrilateral which touches the circle at 4 points P, Q, R and S. So ABCD is a quadrilateral. ABCD is a quadrilateral. It is a quadrilateral and touching the circle, touching the circle at P, Q, R and S. At point yes, and at point yes. Now what we have to prove here, it is to prove that TPT, what we have to prove here, this is given ABCD is a quadrilateral and that quadrilateral is touching the circle at 4 points. Side AB is touching at P, side BC is at Q and side CD is at R and side AD or DA is at A. So what we have to prove, that is AB plus CD is equals to AD plus BC. So how do we prove this? So what is theorem 10.2 says that if you observe the figure here, it is point A, point B, point C and point D. From point A, the two tangents AS and AP are drawn. Therefore, AS and AP both are equal. Similarly, from point B, BP and BQ both are equal. Similarly, from point C, CR and CQ are equal. From point D, DR and DS are also equal. That is by using theorem 10.2. So how do you prove this? It is so here AP is equals to AS, AP is equals to AS and PB or BP is equals to BP is equals to BQ, then it is BQ and CR is equals to CQ, CR is equals to CQ and DR is equals to DS. How they are equal? The lengths of the tangents, lengths of the tangents drawn from an external point, drawn from an external point are equal, drawn from an external point are equal. They are equal here it is. So you take this as equation 1, equation 1, equation 2, equation 3 and it is equation 4. So add all the equations, that is equation 1 plus equation 2 plus equation 3 plus equation 4. So what we get on left hand side? AP plus BP plus CR plus DR, that is equals to RHS. We get it is AS plus BQ plus CQ plus DS. Now you rearrange them here. AP plus BP is equals to what? AP plus BP, from these two what we get, it is AB. We get it is AB plus CR plus DR. CR plus DR. So this is DR and it is CR. By adding these two what we get? CD, that is equals to, now AS and DS, rearrange them. AS plus DS plus BQ plus CQ, BQ plus CQ, that is equals to AS plus DS is equals to what? AS plus DS is equals to what it is? AD plus BQ plus CQ is equals to what it is? BC. Therefore, what we have here it is AB plus CD, that is equals to AD plus BC. AD plus BC. Hence it is proved. Hence it is proved. So it is a simple problem. We use theorem 10.2 to prove this. So here point A is the external point to this circle. From this point A, two tangents AB, AP and AS are drawn. Their lengths are equal. That is, lengths of the tangents drawn from an external point are equal. Similarly, BP and BQ and CQ and CR, DR and DS are equal. We get four equations. By adding these four equations, we will reach to our result. AB plus CD is equals to AD plus BC. So this is the way how to prove this. The same concept will also apply for proving what is a parallelogram as a rhombus. A parallelogram as a rhombus. Is it clear, children, how to prove this? Now, the 11th question. Prove that the parallelogram circumscribing a circle is a rhombus. How do we prove a parallelogram and rhombus? So first, recall the properties of parallelogram and rhombus. What is a parallelogram? A quadrilateral in which opposite sides are equal and parallel to each other and opposite angles are equal. What is a rhombus? A rhombus is a parallelogram in which one pair of adjacent sides are equal. One pair of adjacent sides are equal. Then that parallelogram is a rhombus. So to prove this as a rhombus, this parallelogram ABCD as a rhombus, what we need to prove? We need to prove AB is equals to AD or AB is equals to BC or BC is equals to CD. That is, any one pair of adjacent sides are equal, then that parallelogram is a rhombus. So what we have to prove? We have to prove parallelogram ABCD is a rhombus. To prove that a rhombus is a parallelogram if one pair of adjacent sides are equal. So finally we need to prove AB is equals to AD. Now how it is proved, we will discuss in detail. So what is given here in this question? It is given ABCD is a parallelogram. ABCD is a parallelogram and touching the circle or touches the circle at points P, Q, R and S. Parallelogram means opposite sides are equal. That is, AB is equals to CD and BC is equals to AD. Two pairs of opposite sides are equal. Now what we have to prove? To prove that, what we have to prove? ABCD is a parallelogram. Sorry, ABCD is a rhombus. We have to prove it is a rhombus. So how to prove? Simple. By using what it is? The concept of 10.2, theorem 10.2. That is, in this parallelogram for this circle, it is AB, BC, CD and AD are tangents at point P, Q, R and S respectively. Now, point A, point B, point C, point D will act as external points to the circle. Now, the tangents drawn from external point A, that is AP and AS are equal. Similarly, from point B, BP and BQ are equal. Similarly, from point C, CR is equals to CQ and from point D, DS is equals to DR. That is, the lengths of the tangents drawn from an external point are equal. So here it is. So here AP is equals to AS, PB is equals to or BP is equals to BP is equals to BQ. This is equation 1 and it is equation 2. CR is equals to CQ, equation number 3, and DR is equals to DS, equation number 4. How they are equal? Lengths of tangents drawn from an external point are equal. From an external point are equal. They are equal. Now add this all the equation. Equation 1 plus equation 2 plus equation 3 plus equation 4. So what we get? AB plus BP plus CR plus DR, that is equals to AS plus BQ plus CQ plus DS. Now you see here AP plus BP. AP plus BP is equals to what it is? AB plus CR plus DR. CR plus DR. CR and DR, it is CD, that is equals to RHS. What we have? AS and DS. AS and DS. What we get is AS and DS is equals to AD plus BQ plus CQ. BQ plus CQ will give us what it is? BC. Now we know that AB and CD are both are opposite sides and they are equal. So this can be written as AB plus CD can be written as what again? It is AB, that is equals to AD plus BC is equals to what it is again? AD. Opposite sides of the parallelogram are equal. That is 2AB plus AB, it is 2AB, that is equals to AD plus AD, it is 2AD. So now 2 and 2 are cancelled, we get AB is equals to AD. What are AB and AD? They are adjacent sides. AB and AD are adjacent sides of the parallelogram, are equal. Therefore ABCD is a rhombus. ABCD is a rhombus. Why it is a rhombus? Because one pair of opposite adjacent sides are equal, AB and AD. That is one pair of, or a parallelogram in which a parallelogram with one pair of adjacent sides are equal. Adjacent sides are equal, then it is a rhombus. If one pair of adjacent sides are equal, a parallelogram with one pair of adjacent sides are equal, then it is a rhombus. Therefore ABCD is a rhombus. So like this, by using the properties of parallelogram and rhombus, we can prove this parallelogram circumscribing a circle is a rhombus. So using the concept of lengths of tangents drawn from an external point to a circle are equal. Is it clear, children? I hope you understand today's concept and today's class. Now your homework is exercise number 10.2, question number 5 and question number 6. Complete the given homework. Thank you very much.